Hi guys, Mr. Voight here. Today is our first video for IXL. We're going to start with multiplying decimals, letter I, and we're going to start with number 1, I.1. So this is estimating products of decimals. Let's just go in and get started. All right, so it says estimate the product, round each factor to the nearest whole number, and then multiply. Okay. Estimate, which means that you're rounding, either up or down. The product, which is the numbers that you're multiplying. And the factors are just the numbers, okay? Round each factor, that's referring to the numbers, okay? So in this case, we've got 8.41 times 8.93. So with 8.4, you want to look here. Let's see, 8.4 is approximately, look here, right? Look here at the 4. Is that less than 5? Yes. So if it's less than 5, you round down. So this is actually approximately 8.0. And the other number was 8.93. So 8.93. Okay, so you don't need to worry about the 3 so much, okay? Look at the number in the 10th place, the 9. That's greater, 5 or greater goes up, right? So this number is approximately 9 whole. Okay, and so then you're estimating the product. So 8 times 9, we'll put that here, 8 times 9 equals 72. Okay, we're gonna pop that in here, 72. Awesome. Okay, so next one, we've got 7.83. 7.83 is approximately, so look at the 10th place, that's the 8. Okay, 7.83 is the 8 5 or greater? Yes, so we round up to 8. All right, and the other number is 4.52. So 4.52, and is the 10th place 5 or greater? Yes, it is. So that's approximately 5 whole. So then you're going to multiply 8 times 5 equals 40. Okay. And that's kind of how this is going to go. All right, the next example is 5.6. 5.6 times, well, let's go ahead and estimate that. 5.6 is really closer to 6, okay, because the 6 is in the tens place. That rounds up. And then the other number is 4.2. 4.2. And 2 is less than 5, so you round down, so that's actually 4. 6 times 4 equals 24. So why do we do this? Well, it's always important to know how to estimate any kinds of operations, because in your mind, it helps you understand whether the outcome is reasonable. Okay, so it helps us really do math quickly in our head, or when we're solving problems, it helps us understand if an answer is reasonable. Okay, if an answer is not reasonable, but we know our estimation is correct, then something is off, and it helps us avoid making mistakes. Okay, so I'll do one more from here, and then I want to move on to the next part, because I feel like this is pretty straightforward, and you guys know rounding pretty well. So let's go to the next question. 2.62 is approximately what? Times 0.6. Okay, so 2.62. 2 is a whole number, right? 6 tenths place, 2 hundredths place. So 0.62 is really 62 hundredths, or 62 out of 100, right? So just explaining some place value there. Okay, so 2.6, well, this actually is closer to the number 3, okay? Rounds up. The 6 rounds up to 100, or 62 is closer to 100 than it is to 0. 0.6, again, that's almost like 60, right? If you imagine there's a 0 in the hundredths place, that's 60 out of 100. That would round up to 1 whole. Okay, then 3 times 1 equals 3. Okay, we'll enter our answer here. Did we get it? Yay. Okay. Now, I know that there's a couple that 6 times. Maybe it's in the next lesson. But let me just show you one. Let's just make one up. Let's just say that this was 2.62. That's approximately 3. And let's say that was times 0.04. So 0.4 you would round down, right? So that's actually, that rounds down to 0. Then you have the product of 3 and 0 is 0. Okay? So in my mind, that's a little odd, because if you're trying to estimate, just to help you know quickly, right? 2.62 times 0.4, well, we know it's going to be a number greater than 0. But if you were estimating, it's just 0. Okay? So for quick math. All right. Let's move on. Let's move on to the next part here. So the next part is pulling it up here. We're going to go to HI. Okay, multiply a decimal by a power of 10. So multiply a decimal by a power of 10. Okay, once you get the hang of this, it really starts to kick in. This is IXI.2. All right, so to start with, we have 0.7 times 10, 0.7 times 10. When you're working with decimals, okay, the biggest thing for me is to just multiply. What is 7 times 10? 7 times 10 is 70. Okay? Then you always assume, okay, just assume that the decimal place is here on the right. Okay? Because 7 times 10 would be a whole number, so you'd have 70 whole. But the actual is 0.7. So this is a number less than 1. Okay, a number less than 1 times 10. Well, it doesn't make sense that 10 times 7 is 70 if we're multiplying a number less than 1 10 times, right? The number is going to be smaller. So here's the kind of strategy. You look at how many places the decimal moves over, okay? So in this case, the place value is just 1 place. So we're going to move the decimal over 1 place. Okay, so 10 times 0.7 is actually 7. Okay, how many places is the decimal? You want to look at both numbers too. So this one, it's already whole. So how many places would you move the decimal? You move the decimal 1. So you move it over 1, and then you get 7. All right. So let's try that. Wonderful. Okay, the next one is 0.17 times 10. 0.17 times 10. Okay, well, I know that 17 times 10 is 170. And if I assume my decimal place is on the right, and then I look here, how many decimal places do I have in the two numbers that I'm multiplying? Well, in 17, I have 2 decimal places, okay? So I'm going to move my decimal place over 2 times. 1, 2. So our new number is 1.7. Okay. Looks like we got it. So next one, 100 times 0.65. 100 times 0.65. Okay, so I know that 65 times 100 is 6,500, right? And I have a 2 place value decimal here, 1, 2. So I scoot my decimal over twice, and that gives me the number 65. Or you can just type in 65. Next is 100 times 0.2. So sometimes when I was learning this, I'm thinking of, 100 times anything is going to be a number greater than 100. But you got to be careful. If you think of it where you say, well, what would be 2/10? Or, well, that's literally 2/10. 2/10 100 times. So that would be like 2/10 plus 2/10, right? 100 times. Well, in that case, you would get what? Well, it'd be 200 tenths, right? And then how many times does 10 go into 200? 20. Okay, so you can think of it as fractions too. Okay, or we can use this decimal strategy that we've been going on. So 100 times 2. So we're just leaving the decimal out to start with. What's 100 times 2? Well, that would be 200. Okay, how many decimal places do we have to move? 1. 1 place over. So starting from the right, going over to the left, we move over 1 decimal place, so it's 20. See how it matched? 20, 20. Okay, next one, 68 times 100. So in this case, we've got 0.68 times 100. So I'm just going to multiply as if the decimal wasn't even there, okay? 68 times 100 is 6,800. And now I count my decimal places. 1, 2, right? 1, 2. So I do that here. 1, 2. So it's 68. Okay? And we keep going. Let's do this last one with 1,000. So let's see, 0.77 times 1,000. Okay, so it'd be 77,000. And then what do? Well, we look at the 77. How many place values? 1, 2, right? We move it over. 1, 2. 1, 2, So it's really 770. Okay, and so on. Okay, you just keep going. You just multiply 10,000 times 4, you'd get 40,000. And from 40,000, you move the place value over once. So 40,000, move it over once, turns into 4,000. Okay? That's all there is to it. Multiplication. All right, so let's go back, and we're going to do the third. We're going to do the third now. Letter I, point 3. Okay. Multiply a decimal by a one-digit whole number. Okay, multiply a decimal by a one-digit whole number. So here we are, I, point 3. So 5.9 times 2. 5.9 times 2. Okay, so this is where estimation helps, right? Because 5.9, well, that's almost 6. So I know that my product is going to be close to 12, right? Probably slightly less than 12. So let's jump in. Let's just multiply as if the decimal wasn't even there, okay? So 2 times 9 is 18. 2 times 5 is 10, plus 1 is 11. And then we move our decimal place over once. 11.8 is our answer. 11.8. 8. Oh, how's you go backwards here? That's interesting. Okay, 6.7 times 5. 6.7 times 5. Again, just multiply as if there's no decimal there. So 7 times 5 is 35. 5 times 6 is 30, plus 3 is 33. And then you want to look at both numbers. That's where some people make mistakes. I mean, we only have one decimal number right now. But if you have two decimal numbers, you have to count all of the decimal places and move it over for both. But right now, we only have one decimal number, so we move it over once. Bloop. 33.5. Right? And 6 times 5 is 30. Okay? And then 0.7 times 5. You can also think of it that way if you really want to. You could do 6 times 5 equals 30. And then 0.7 times 5 equals what? Okay? And then add it on there. Right? Did I make a mistake there? No, it'd be 35. Point. Be 35, and then you move it over 1. So 3.5. Okay. All right. 33.5. Okay, 8.1 times 1. 8.1 times 1. Well, 8 times 1 is 8. So I'm thinking maybe it's just slightly larger than 8. 1 times 1 is 1. 1 times 8 is 8. I move it over 1 decimal place. 8.1. There you have it, folks. Let's just do one more example, and I think you'll be able to handle the rest on your own. If you don't, just email me or give me some feedback. Email me and let me know if you could use more explanation or something that I'm not doing that would help you, give me some feedback so I can make those adjustments. So in this last one, we'll do 3.8 times 4. So estimating, well, I know this is going to be probably just less than 16, because 3.8 is almost 4. 4 times 4 is 16, so I know my number should be just less than 16. Let's find out. 8 times 4 is 32. 4 times 3 is 12. Plus 3 is 15. Okay, so notice I'm just multiplying this as if the decimal's not there. 38 times 4 would be 152. Then I just count how many decimal places are here, and there's just one decimal place. So, one decimal place. Our answer is 15.2, right? Just less than 16, and we're good. Oop, not 51. Submit. Super duper. Okay, guys, have a good day. Hope this helped. Bye.